Photochemistry. Photochemistry is the studies of interactions of electromagnetic radiation with matter resulting into a physical change or into a chemical change. Primary process: one molecule is excited into an electrically excited state by absorptions of a photon. It can undergo a number of different primary processes. Photochemicals. The process are those in which the excited species dissociates, isomerizes, rearranges, or react with another molecules. Photophysicals. Process including the radiative transition into which the excited molecules emit lights in the form of fluorescence or phosphorescence and return to the ground state, and the intermolecular non-reactive transitions in which some or all of the energy of the absorbed photons in ultimately covered to heat. So laws governing absorptions of lights. Lambert's law. What is Lambert's law? This law states that decreases in the intensity of monochromatic lights with the thickness of absorbing medium is proportional to intensity of incident light. Beer's law. It states that decreases in the intensity of monochromatic lights with the thickness of the solutions is not only proportional to the intensity of the incident light but also to the concentration C of the solutions. The laws governing photochemistries. Crotth's Draper law. Only the light which is absorbed by the molecules can be effective in producing the photochemical changes in the molecules. Stark-Einstein's law, second law of photochemistry, it states that for each photons of lights absorbed by the chemical systems, only one molecule is activated for the photochemical reactions. There the energy absorbed by the 1 mole of reactive moles given by the E equal to NHV. This energy is called as an 1 Einstein. What is luminescence? The glow product into the body by the methods other than actions of the heat. The productions of cold light is called luminescence. It is three types. One is chemiluminescence, second fluorescence, third phosphorescence. Here, what is chemiluminescence? The emissions of light in chemical reactions at ordinary temperature is called as a chemiluminescence. Example, light emitted by the glowworms. What is fluorescence? Certain substance when exposed to light or certain other radiations absorbed by the energy and immediately start re-emitting the energy. Such substance are called fluorescence substance and the phenomenon is called as a fluorescence. Example, organic dyes such as eosine, fluorescence, etc. Vapor of the sodium, mercury, iodine, etc. And the next one is the phosphorescence. What is phosphorescence? There are certain substances which continue to glow for some times even after the external light is cut off. The phosphorescence is a slow fluorescence. The fluorescence and phosphorescence in terms of the excitations of electrons. Singlet ground state, singlet excited state S1, pair of electrons with opposite spins but each of the different orbitals. Triplet excited state T1, a pair of electron which is parallel spin is different orbitals. The excited species can return to the ground state by the losing all of its excess of energy by any one of the paths shown in Jablonski diagram. So here you see the Jablonski diagram. So S0, S1, S2. So first is H nu is absorptions. It's go to ground state to excited states. Allowed signal states in the internal conversion. So H nu A, it's another interconversation fluorescence will be appeared H nu F, and the intersystem crossing the H nu B is phosphorescence. It is called as a forbidden triplet states due to the spin conversation. So the Jablonski diagram explained the first step is the transitions from the higher excited state singlet states to the lower excited singlet state S1. This is called as a internal conversion IC. It is a non-radiative process and occur in less than 10 to the power of 11 seconds. Now from the S1 to S1, the molecule return to ground state by any of the following paths. Path 1, the molecule may lose rest of the energy also in form of heat, so that is completed path is a non-reactive radioactive. And path 2, the molecule release the energy in form of the light or UV radiation. This is called as a fluorescence. Path 3, some of energy may be lost in transform from S1 to T1 in form of heat. It is called intersystem crossing ISC. This path is non-radioactive. So path 4, after the intersystem crossing, the molecule may lose energy in the form of light on going from the excited triplet state to the ground state. This is called as a phosphorescence. So this is a Jablonski diagram. So next ones we are going to see the photosensitations. What is photosensitization reactions? An electrically excited molecules can transfer into energy into seconds species, which then the undergoes a photochemical process, even though it was not itself of directly excited. Mercury acting as a photosensitize. D plus H nu is equal to D3, and D1 is equal to gives to D3, D3 plus A plus D plus A3, and A3 is the product sensitization, 3D is the product quenching. So this is for the reactions we called as a S not to S1. This is a photosensitization reactions. It's called as this is the photoreductions of carbonyl compound. The ketone undergoes to photoreductions in the presence of the variety of the hydrogen atom donor other than secondary alkyls. The reductions of the benzophenone in benzene in a Pyrex tube by exposing it to sunlight for a few days. The reduction takes place in the presence of benzohydrol. So this is a benzophenone. The benzohydrol gives to photochemical the Pyrex. The final product is benzophenacol formed. The mechanism, the first step is exciting of the benzophenones to the N pi star state, which is intersystem crossing to the N pi star states. Hydrogen absorbs from the algal gives to diphenyl hydroxymethyl radicals, which combines with the form of benzopenacol. The excited ketone can be reduced by the tertiary amines. The key reactions in this case of electron transfer from the amine to ketone product producing the cation radicals and cation radical from the amine. So photochemical oxidation reaction. So incorporations of oxygen in the presence of UV lights is known as the photochemical oxidation. There are the two mechanism of the photo oxidations. The first is Backstrom mechanism, which is also known as photosensitization oxidation mechanism. So its main characteristic observed for the hydrogen by the sensitized, it is excited in triplet state following by the additions of oxygen to the newly created radicals. This type of photooxygenations is known as type 1 photooxygenations. And then the second mechanism is known as the photosensitizing oxygen transfer involving the direct combinations of the substrate with oxygen. There are two proposals regarding the state of oxygen involved. This type of photooxygenations is known as type 2 photooxygenations. Senquick's favor on oxygen transfer steps into which is triplet sensitization form of adduct, which is triplet oxidations. Thank you.